Thanks very much. I'm really pleased to be here, also for the invitation. The title of the talk is Big Data Critique, and in particular, what I would like to do is talk a little bit about where big data are going. So that's my one German word that I know, wohin. And I want to talk about a very, very recent development in big data, where it has shifted slightly on the Gartner hype cycle, moving from a particular point of hype over now to the first ideas of disillusionment. So I want to talk a little bit about where some of this potential disillusionment about big data is coming from, before we move on to the sort of kind of way forward in the future of how to enrich big data with other kinds of data in order to have it be useful. Now, I think the most seminal and most significant big data contribution has been historically has been recently has been Google Flu Trends. Now, Google Flu Trends, I think, kicked off 2009, 2010, somewhere around there. And for the first time, the web's sort of idea of the place that can anticipate or predict what's happening in reality, what's happening in life, actually occurred. Google Flu Trends, as you will have heard most probably, looks at where people are searching for flu and flu-related terms like coughing, sneezing, etc. And Google Flu Trends, for a number of years, was able to predict something like 7 days in advance of the standard techniques where flu was happening. So the incidence of flu was predicted on the basis of people searching for flu-related symptoms and geolocating where those searches were coming from. So this hearkened to a day when there would be predictive algorithms, predictive search in particular. Now, something happened not that long ago that sowed the seeds of doubt in big data, and that was first came out a paper in Science, and then later in Nature a year after, Science in 2013, by colleagues at Northeastern University, David Lazaire, and then later as well, where it turns out that Google Flu Trends hit a bump. Google Flu Trends was predicting twice the amount of flu than was actually reported for by the Centers of Disease Control. So they were overestimating the rate of flu by 2 times. Now, what had happened? What went wrong? Now, there's a lot of speculation, but one of the things that went wrong is that scientists aren't really able to look into how Google Flu Trends works properly. If you use Google Correlates, as many of you might know, you can get a number of the queries that could be used to do sort of predictive algorithmic work, but we don't know exactly what queries they were using, so we couldn't replicate it and thereby, in some sense, fix it. The speculation is that Google is confusing two things that are fundamentally different. On the one hand, queries in the wild about what's going on in life, and queries that relate to media attention. So if the amount of media attention to flu goes up, perhaps people are searching for flu and more often because of the media coverage, not because they have flu themselves. And so this is one of the reasons why it might be overestimated. So this is the larger question about the extent to which one with predictive algorithms can actually remove quote-unquote media effects. So most recently, this was a couple of months ago, this is the famous Gartner hype cycle. I guess people in this room will all have seen it before. Big data for a long time was on its way up and hit the top of the hype cycle sometime in 2013, until very, very recently, where it has now reached this moment of disillusionment, according to Gartner. Now, Gartner has very specific triangulated methods to try to figure this out. But the question is, in some sense, what happened? Is this to blame? Is Google flu trends to blame, or are there some other general trends in big data? So what I want to do is very, very briefly just talk about 5 of the major critiques of big data. You may know them. If you don't, now you will have at least seen them. And then subsequently, right at the end, I'll say something about how to move beyond the critique. Okay, here's the first one. The big data critique. The first one is that big data represents a major shift in let's say, sort of reputational structure in society. So if we feel that big data is our road to truth, then only those who can handle big data are the ones who can be trusted, or the ones who have reputation. So we're now moving from a shift to those who have the large-scale infrastructures, and those who have the data scientists are the ones with the reputation. So now funding and contracting work is now shifting over to the sort of, let's call it, the big data handlers. That moves the analytical capability away from others who traditionally had it to the data scientists. So this is the first one. The second critique is that we're also changing our mode of analysis. So we are moving from a kind of means by which we interpret things to looking for patterns. So we're shifting from a kind of hermeneutic way of thinking, so interpretation, to looking for patterns and pattern recognition. So we're moving away from what we once called close reading to what is known as distant reading. So we're reading reality, what is happening, and phenomena, and interpreting phenomena from a distance. And what I wanted to point out really briefly is the kind of results that we get from big data analyses. So big data tends to look at very, very broad trends, and apart from the broad trends, the outliers. So in some sense, what you get from a big data analysis is the obvious and the obscure. And these are your outputs. Now, your outputs are increasingly looking like this. This is a piece of work that I did. It's a co-hashtag analysis, meaning which hashtags in Twitter appear in the same tweets most significantly, and it was an analysis that I did of how Dutch civil servants use Twitter. But what I wanted to point out is what you increasingly get are these kinds of outputs. So we have the return of the graph. And the graph is not something that is necessarily that easy to interpret. What you see here are 5 different colors. Those represent particular clusters, and what one generally does is you name a particular cluster. So what you get out of the analysis is, okay, these are your 5 clusters so named, and and relying on the graph requires sort of, let's call them new literacies. So we now are shifting to relying on the people who are able, in some sense, to read the graphs and grasp the visualizations and grasp the big data visualizations. And there's also the question of whether good big data visualizations are at all possible. And increasingly, what we're seeing is more and more of these kinds of graphs with and also quite standard outputs from our network analysis software, whether it's Giphy or something else. So we're seeing quite standardized output, which require quite a lot of literacies. Now, one of the critiques that has been raised from these kinds of pictures, or these sorts of figures, is whether or not we suffer from what's called apophenia. Apophenia, which is a term that indicates that we think we're seeing patterns when in fact there are none. So we think that we have these patterns because of big data, standard big data analytical outputs, but in fact these patterns might not exist at all. They might be a product of the software. They might be a product of a sort of setting that we turned on or didn't turn on. So this is one of the major challenges. The fourth one is that we are also seeing, let's say, an organizational shift, just generally speaking, in companies as well as in academia as well as in government. You're seeing an organizational shift whereby we are now beginning slowly to rely on these sort of small teams of data scientists who have the special access and the special privileges to get to the data on the one hand, and on the other hand, who are able to actually analyze it and are able to handle it. And this sort of shift means that some other analysts, ones that we probably have been relying on traditionally, are being somewhat marginalized because they're less able to analyze the pictures, less able to actually work with the large-scale data. So what are called thick data specialists, those who traditionally have known very well the context, are being, in some sense, less relied upon. And so you might get these sort of organizational tensions where the sort of classic, the thick data people, as they're called, the contextualists, have less insight or are being asked for less insight than the big data specialists. Okay, and then the last one that I'll touch on really briefly is we're currently seeing a massive shift in the kind of our preferred data sets. So what are our preferred data sets? Well, our preferred data sets are those that are easy to get to. So Twitter, for example. So we can get to Twitter quite easily, and we can make analyses of what's happening in society according to Twitter. But these signals are the ones that are the most available, and we're increasingly relying on those. We're not relying on those, or we're not going out and looking for new signals. And this is a general critique. I mean, we might call it analytical laziness. The fact that we're relying more and more on what's available, the APIs, open the API data streams, and let's do our analysis, as opposed to actually going out and doing the nitty-gritty work to find those signals which aren't in the APIs. So there are there's the sort of quote-unquote available signal critique, whereby the signals that we have available might not actually provide good societal coverage. They might be actually quite skewed. So the idea that big data will take over from the sample, I think, is a problematic idea. Okay, so just concluding very briefly. So how do we go from this sort of what Gartner calls the sort of dip, the disillusionment, the trough, or the dip of disillusionment, to the slope of enlightenment for big data? One of the ways forward is in fact to think about how to reincorporate these other specialists. Right. So I mean, I just put down the other specialists. There are these other new data names arising. I used the term thick data previously, but there are also the small data specialists. Those are the ones who are good at a series of case studies. Right? So the small data does case studies, the thick data does context. There's also the broad data specialists, which triangulate a series of different kinds of data outputs, or all data is quite similar. So try to incorporate these other types of data specialists into your analytical undertakings. I'd like to thank you very much for your attention.
But before we start the discussion, I'd like to ask one short question to the audience. From what you've heard, and you're all experts, or most of you are experts in the field of big data, data analytics, predictive technology, and so on. Who of you thinks that big data algorithms and predictions will improve this world? Just show me your hand. Who will think it will be a better world with big data? And who of you thinks it will make this world worse? So that's fantastic. So that's quite not the way I'm used to it in German conferences, because in Germany we're always very quickly on the dystopian side. And to really push this a little bit further, I'd like to ask the panelists to give them a very hard task. And the task is, imagine daily life in 2020, so 5 years ahead, when algorithms and predictions really had a huge impact on our life, on our daily life. You can really feel the algorithms in your daily life. And just imagine a positive utopia. Not a dystopian idea, but it really will be a better world. Just tell me a little bit, what will daily life look like? What will be the positive impact of algorithms? So we start with
It's
Klaas.
me first.
Yeah.
Okay. Yeah, I actually thought about it quite a lot, because it's a really difficult question. So for me, it would be perfect if I don't have to drive my car myself. So I'd really love to have the car drive the way to wherever I want to go, and I don't need to do it. So that would be perfect. And I don't want to clean my house. So that's the other thing. So it would be perfect to have a robot who would work for me. And inside robotics and inside driverless cars, we have to use a lot of predictive algorithms to actually make it work, and a lot of other stuff, of course, and a lot of things. So for me, that would be a perfect world. Not to clean my house, not to drive the car myself. That would be perfect.
Okay. Volkmar?
I think very similar. I live in the Bay Area, so it's actually knowing when the traffic will be there and not having to deal with it. I think also it has a lot of impact. I mean, we are spending so much time in cars and transportation in general. Removing that and actually using the information we have actually at hand and changing the way we are behaving, stretching things out so that we are not constantly fighting for the same resources. I think that would probably be the biggest impact.
Okay, so we have self-driving cars and our homes will be clean. What will be next, Richard?
So I'm thinking about this a little bit from a kind of analytical point of view. So what sort of analyses would I like to be able to do? And I was sort of, I mean, I've always thought that I would like to be able to sort of geolocate, you know, hate speech, geolocate fear, where people are sort of most uncomfortable, you know, anxiety. These sort, like, I mean, not necessarily in, you know, in order to create this sort of over-awareness, so that the authorities will step in immediately, but instead be able to actually have a sort of, you know, much broader understanding. I mean, I think about where people are searching for flu, but I'm also thinking about, you know, where people are searching for these other things, and whether or not I can actually understand the extent to which you know, Islamophobia is rising in Denmark, and where. And so analytically, this is what I'm interested in from predictive algorithms in the future.
Anna?
Despite of the self-driving cars, I would think an even a better aspect or more to that aspect would be really smart cities with smart traffic lights, for example, who adjust to the traffic and just see where the roads are free and where to put the traffic on. Despite of that, what I would really like to have would be a really smart recommendation engine, which really for example, give me travel ratings from my personal perspective, because the engine would know which kind of books I read, which kind of movies I watch, which kind of magazines I read, and with all that information he could really give me a good insight on which kind of hotel or which kind of resort would really fit my needs. With that case, it's also a thin line between utopian and dystopian, by the way, because having all that data in one place, you can easily have one dystopian way of viewing that thing.
Okay, thank you very much. So just to delve in on some of the points you've raised, maybe start with Anna. I've one question. You're working in advertising, in research with large data sets. So what kind of skills are needed to make sense of large data and not to fall into this apophenia idea to see patterns that aren't there? So I think it's really part of your job to do pattern recognition. So what are your recipes?
Yeah, that's interesting, because it somehow connects to the fourth point you raised, because what I would understand as working with the big data or being a data scientist is not just being able to handle the data in a technical way, so crunch the data, and not just have the analytical skills to look at the data and work with the algorithms, but also have the ask the right questions, so have the business sense coming into that job. So I think the most important thing while working with big data is, despite of the technological and statistical and analytical things you have to bring in, is really to know how to ask the right questions to give the data or make the algorithm give you the right answer with that data you have. So I think one of the most important things is to really have all the three things in place.
What are some of the questions you're asking a data set?
How are you feeling today? No, it depends on how you want to use the data. So the question depends on your business needs in the end. If now I'm working in online advertising, so the question and what I need from the data is to make predictive ads work in the best possible way. So I need to have data which can help me to fit that very KPI best. If I would work in a different environment, if I would work at the in high-frequency trading, for example, my question to the data would be a different one. So that is, I think, the most important thing about.
So, Volkmar, you're also working with, as I understood, with mobile data, programmatic buying.
Yes.
So what are your questions to data sets?
I mean, ultimately, it's probably very similar with what we are doing and the questions you're asking. You know, if you look at advertising, in many cases it's spam, right? I mean, I really don't like advertising that much, despite that I'm in the business. And so ultimately, you're trying to match, you know, the advertiser message to the consumer who actually is interested, right? So there is no benefit in sending spam, because ultimately it's only, well, we cannot target well. And so we use big data to try to identify, you know, the common set of people who have interest in the particular product we are offering, or, you know, an advertiser is offering. And ultimately what you're trying, in many cases, you don't have upfront information. So you know, get an ad, and then you're effectively trying to slowly narrow it down to really the people who have interest. And I think to a certain extent, I feel comfortable with data privacy things, which were mentioned a couple of times already, because we are on this side, we are not trying to single out the individual, but we are looking at these larger trends of interest. We are not trying to target an individual. And I mean, personally, I don't like my data being, available. I'm very careful. I disconnected from Facebook. I'm not using Twitter because I don't like the level of detail which actually becomes available. So I'm comfortable with the broader scale of, here is a population of, let's say, 100 million people, and out of them we may identify 10 million who have a particular interest, but singling out the individual and potentially even discriminating them is a true concern.
And you're doing this all in real time. So this
yes.
is, I think, one of the things that's very interesting about big data. So it's not only the large data sets, but also the speed it all comes in. But what's the current state of the art? How fast is big data, and how fast is it going to become?
So, I mean, I used to work in high-frequency trading before I did advertising, so things have dramatically slowed down now.
Okay.
So in advertising, imagine most of or a large percentage of the ads or ad placements get sold in an eBay-like auction, which is about 100 milliseconds. So this includes, latency on the wire. So
it's very slow.
It's very 100 milliseconds is very slow. So I mean, we for example have a data center in Hong Kong, and we can reach Japan. So you have a long distance in between, a couple of milliseconds. Then on the other hand, if you go into high frequency trading, there you're looking at like 5 microseconds, and sometimes 10. So if you are really slow. So, and then, it becomes really a war about who has the fastest lines. People are building Wi-Fi links between major cities to cut down, speed of light on a wire is only 65%. So if you go in vacuum via Wi-Fi link, you get to like 98% of speed of light. So you're a little bit faster. So it's a technology war out there, because over 15 years, the financial industry has figured out how to cut out all the fat, right? I mean, they started at 5 to 10 milliseconds trading, and now it's down to 5 mics. So that's the speed where we are.
Okay. So it's kind of interesting, because when we're talking about connected homes and things like that, we always have this smart fridge as a kind of archetype of the Internet of Things, and we learned that the smart fridge isn't that smart. And if we're talking about speed, then it's always finance and a little bit advertising. Okay, we've learned that it's more slow. It's really a slow industry. But are there any other areas that really are needing this speed of big data, Klaas?
Machines, for example. So if we talk about this, what we call Industry 4.0, and all the machines out there who are able to produce data, maybe not today, but soon, are able to produce data from all their components, sensors, etc. We know from companies where each sensor produces several thousand key value pairs every second of data. So that's a huge amount of data, and it's fast data. And I think that's where we have to deal with a lot of data streams at the same time, and have to be able to distinct the data we need now from the one data we don't need now, and store the one, and the other have to analyze in time and in real time when we really need to go into this. So that's a huge field and huge playground where we have to deal with data the next years, next 20 years or 50 years, actually.
And you're in the field for like 5 years or so. You're working with big data companies, big data analytics, so really very early on. What has changed in the last 5 years? Are there new questions, new approaches?
I think what has really changed, and that changed not last year and not the last 5 years, that change is changing right now, is that we really start working with big data. We really start doing projects on data. We don't talk about it. There's a lot less conferences. Well, this one's fantastic, but there's a lot less other ones. and there's not this hype anymore. But I don't think that we have this throw of disillusionment, or how it's called. It really just gets going now. So we really start now. We get a lot of questions, a lot of companies who really want to start now, who learned the first things that they need to learn about technologies, about how to ask first questions and how to start first projects, but they start now. And that has changed. Like, we don't talk anymore, but just do it. And that's perfect. So it's good.
How far has it changed academia? When I was studying sociology years ago, then it was really very small data, and if there was any data at all, you had to go out and collect data. You didn't have any data points. So right now there's this talk of computational sociology, computational economics, and so on. Has it really been transferred, or it has changed into this mood of hands-on? We're just doing these big data analytics?
Yeah, I mean, so I mean, I think that in so many of the sciences 10 or 15 years ago, what you imagined was some sort of, I don't know, room that you would walk into, and there would be sort of, you'd be surrounded by data, and you kind of would explore it somehow in some sort of virtual reality sense. So from like this data exploration paradigm, I think we're moving from a data exploration paradigm to a data storytelling one, or data-driven journalism, or so it's less about exploring it and more about telling stories with it, and making sort of quite strong findings with it. So I think that's the big shift. And just to come back to something that you were mentioning before about where big data are generated, it just occurred to me that, I mean, for years and years, the largest data would come out of CERN, right? It would come out of particle physics. And then even prior to that would come out of radio astronomy. So the huge installations for looking at the stars and the planets and things, and so signal processing and these sorts of things, it was always massive. So I think that the big data is moving out of its traditional sites, right? So those places, and when it moves into these other fields, the computational turns in sociology and the rest, you get a very, very different kind of analytical regime. You get different questions. And I think you're getting a lot, what I call sort of more storytelling. There's also data-driven journalism now, which is also an interesting turn within journalism. So those are some of the changes.
And how do you teach your students to make sense of these wonderful hairballs, these graphs where you don't see anything? So what are the methods? Is there any kind of instrument or approach that can be taught, or is it more experience, hands-on experience?
There's two things. There's a new format, so we now teach in sprint or short form formats, bar camps, sprints, hackathons. So most of the most significant work is done in a week's time, as opposed to a semester. It's 1 week, and then the second thing is that we are trying to move into what we call networked content analysis. So not necessarily staring at the hairballs, but trying to figure out, and this is relevant for I guess everyone, like sort of what is the most engaged with content, for example, on Facebook. So you can output a graph of connections, or you can develop metrics to say that it's this particular video that had, was most liked, shared, had the most comments, or most shared comments, and so we're using the metrics in some ways to return to sort of to update content analysis, for example.
Coming back to one question that we had in this discussion already, the data sources that are relevant now. In his keynote, Richard told about this kind of fallacy that most of the data analysis we are seeing are happening because these data sources have an API, so they can be analyzed. So everything that has an API will be analyzed. Everything that doesn't have an API, there is much less methods, tools, instruments to analyzing this. So Anna, what do you think? What are the most fascinating data sources of the future? What will we discover? What will we think will be more important for big data analysis?
What I could think of, it's maybe not new data sources, but seeing sense in a data source which is not used for a different field yet, for example. So for example, using weather data to predict energy prices, because the new energies would react to weather and would produce more. So for example, using that in that more in that field, or connect data sources to from really different fields to have it used in one field. I think it's not that you will explore really new data, but you would explore new fields of usage for various data. And I think the point you raised with Twitter, by the way, is an important one about what kind of data you use because it's really still you have to look at the type of data. For example, in my opinion, in Germany, Twitter would not be a real subset of a population. It would be a thought leader tool, maybe, something which you can use to make analytics about, I don't know, big data trends, for example, because many people in that field use Twitter, but it wouldn't be the best data. It wouldn't be the best data feed for example, having a subset of a German population with a good age spread or a good gender spread or a good opinion spread. So it's you have every data source you feed in your data, every data source you analyze and think of using. You have to be careful if it's really fits your needs.
Can I add something? I think it's not just a question of which data sources will become more interesting or which are the data sources we should look at, if they are easy to access or not easy to access. It's more the question of what kind of data do we need to produce, which we don't have right now, because we don't have all the data. We have enough data, of course, we have lots of data, but it doesn't mean that it's the right data to answer the question I have. And sometimes we go to a client and to a company, and they say, we have these petabyte stores of data. There's somewhere there, just do something with it. We know there are answers in it, just do something with it. And we find out very, very soon by exploration that data is just missing. It's not there. So we need to create processes first inside their business to produce the data we actually need to make sense of it or to answer this first question. And I think there's a word for it, it's called datafication. So we need to datafy our world a lot more to have the data we maybe need to answer new questions for, I don't know, car seats and floors and whatever. There's a lot of research going on how to datafy just things when we talk about Internet of Things, for example, or how to datafy machines. We have to do it. It's not there. We don't have the data.
Volkmar, would you agree? Is big data more a problem of handling large data, or is it the search for new data sources or new data?
I think it's a bit of both. So you know, even if you generate all the world's data, if you don't have the means to actually analyze it in a reasonable time frame, then you know, it's just useless. So, but I agree that I mean, getting data and getting clean data and getting reliable data is a huge challenge. And so I think where we are right now, you know, with the hype cycle, there are a set of companies which actually have relatively easy access to data. So we are either people give the data away for free, it's relatively easily measurable, or there has been, you know, years and years and years of data collection. Like if you take insurance industry, I mean, they have data for 40 years, and so suddenly they start mining it and trying to extract information. Or Google, you know, manages to bring the world's data to, you know, a little search bar and store it, and then trying to analyze it. So I think the businesses we have today are very much structured around data availability, because ultimately collecting that data and normalizing that data and storing it actually has a cost. And as long as you cannot extract an economic benefit out of it, we're not willing to do it. But I think we are, in Portugal, if industries are shifting, and more industries will be shifting, there will be so much cross-use that we are willing to actually collect the data, put sensors on walls. You know, we have now the means of actually transmitting data. I mean, if you look in the physical world, and this is where, I mean, the whole Internet of Things is going toward, the biggest cost is actually getting the data from, you know, a huge planet into a location where we can actually process it. And we are not willing to pay the transmission costs or digging a trench, because it's really expensive to put a cable in. And so we are at a point where we are saying, okay, this data is inaccessible despite that it gets generated, and we could put a sensor on the wall, except we cannot pay for the transmission. Mm-hmm. And to a certain extent, Google and the whole big data movement, MapReduce, Hadoop, all these things led to that at least we dropped the cost of processing it by a factor of 100 or 1,000. We have not solved yet the problem of transmitting the data from the endpoint to a location where we can actually analyze it.
But this doesn't it mean that there will be some kind of a data divide in society, because there are companies who can pay the cost to transmit data and who have maybe control over all the different steps in the data chains, and maybe other companies or people that don't have access to the tools and cannot access the data sources. So will there be kind of a 1% of the data rich people, and there will be the kind of data have-nots? Will it be a divide?
I don't think so. I mean, humanity always found ways that if someone has a really good idea, it will spread and people repeat. And so I think, and ultimately, I mean, if you look back 10, 15 years, if you want to do anything with big data, you give a lot of money to a few companies which give you a humongous database, right? And you pay millions of dollars. And now we are at a point where pretty much anybody in a garage can run a big data business. And so ultimately, as technology gets cheaper, there will be more and more people who have access. And so traditionally, we focus on highest value generation, and usually that's not a lot. So there are very few businesses which, you know, extract humongous amounts of money out of it. Once the prices come down, more and more use cases come to the point that we say, well, everybody has a phone now. I mean, my first cell phone was in '93, and I paid, you know, I don't know, $3, $4 a minute to do phone calls. Now the whole planet has phones, right? And it just brought down the cost, because it is not this thing anymore which is for a very small subset of people. And it's just, you know, traditional introduction of products, and I think this is where we are with big data.
So, Richard, would you agree? Does data science and big data mean democratization or of the means of production data value, or is it more a divide?
I mean, so like what's the traditional definition of good data? So good data is data that's collected at the sort of beginning of its life cycle, is complete, is sort of longitudinal, sort of over time, and is clean. I think that most of the data that we're getting sort of online, also new environmental sensor data, isn't good in that traditional definitions. So I think that a lot of people, you know, will consider that sort of data like too messy or like not valuable enough to work with. So I think there's a huge challenge in that poor data, which is Twitter data, search engine queries, and all these sorts of things. The big challenge there is to develop new techniques, new understandings of what it's good for. So that's my sort of the first reaction. And yeah, well, yes, I mean, I think there already are many examples of the outcomes of data divides the data rich and the data poor. So crowdsourcing applications where you learn about where the traffic is. The people who are avoiding the traffic are the ones who are plugged in, and the people who are stuck in traffic are the ones without the smartphones, right? So it's same with at the airport, those stuck in the lines in economy class and those going through the priority lines. There are these divides, and you're going through the priority lines because you've opened yourself up. Right? So you've allowed your data to flow, whereas other people don't have necessarily those flow lines open. The people who are really concerned about their privacy are also stuck in traffic. So I think that there are these divides.
Anna?
I mean, it's you raised the point that as technology gets cheaper, the access to the data and the usage of data gets more accessible for more people, and therefore it's not something which makes a larger gap between data owners and data users, for example. And if you have that data is the new oil thing in mind, and if you would go for the big data owners as the big oil companies, that you can also argue that maybe really the big players, the big data owners, which keep their data onto in their self, will larger a gap and make maybe that, yeah. And data ownership is something which divides one from another. So it can also widen the gap and wouldn't be something which is accessible or where everybody can make money or is accessible for everyone.
There's this one story that resonates with what you just said, that in the gold rush, it wasn't the people who found the gold who were the winners of the gold rush, but the people who supplied all the different applications and also the people who invented special trousers for the gold searchers. So Levi Strauss was one of the people who came out very rich from the gold rush. So who's the Levi Strauss of the big data movement, Klaas?
Google? No, I don't know. It's I think it's definitely the one who actually owns interesting and relevant data pools, and who is able to create a business from it, and is maybe able to disrupt another one or an existing one, like Google is doing. I don't know, for a lot of businesses probably, and Airbnb, the next rising star, is doing maybe for the travel industry, and a lot of other companies do, and they are mainly data-based and based on recommendations, or build a platform which has a lot of high valuable data underneath. But it's difficult to tell because it's so fast moving right now that we don't really know. We in Germany started talking about big data 3 years ago, maybe, and 3.5 or 4. And now we are here and talk about totally different things, but it's so fast moving what's happening, so it's really difficult to tell. But with a divide, I'd say there is a fair threat that will divide us up in some sort of way. And it's maybe data ownership, but it's the same for education level. So I think it's easier for everybody to use a smartphone than to build a big data startup. So luckily, yes, for you right now. But if we talk about divide, I think we really have to think about, okay, how can we get more people into understanding what can we do with data? What do all these magic algorithms do and these crazy stuff?
But if we just widen the perspective a little bit, what will happen with the developing countries? What does big data mean for the developing countries? I think there could be two possible ways of seeing this. Is it like a scenario where the developing countries are just skipping one stage of development and just jumping right into the modern way of predictive analytics, of algorithmic trading, and so on? Or will they be further behind? What do you think, Volkmar?
I think that there's not a single answer. So I think to a certain extent, there is clearly, this thing is accelerating, but we've seen in previous introductions of technology, like, for example, a cell phone. Right? Cell phones had a dramatic impact on the developing world. They completely skipped wiring, every household, and the massive infrastructure investments. So on the other hand, that also gave them, in fact, they lost a couple of years in industrial usage of those resources. So I think it's unclear at this point, the impact. I think the impact of big data will be felt in those nations, but I think the leadership will definitely happen in the first world, figuring out what are the business models, figuring out how to extract value. And I mean, to a certain extent, we already have this now. I mean, all the companies we are mentioning here are in the States, right? So the US clearly took on the leadership in using, first consumer data, and now they are using industrial data, and are finding new interesting business models around it. And I think Europe has a catch up to do, and think out of the box and leverage the European DNA to find its other way. And I think it's very similar for the third world. The third world needs to find its way to use data. You have telcos in, let's say, India or in China. They charge a fraction on a per subscriber basis, and they can sustain a business. And if a European or a US company would do the same thing, our phone cost would just drop like a rock. It would really enable also the developed nations to come up with new ideas. And I think right now there's not such a price pressure, and I think this is where the developing nations actually have a heads up.
Richard, what do you think? Will it be a neo-colonial big data world?
Yeah, so I was thinking about two things. The first one is we don't only export. When we export technologies, we're also exporting the cultures that come with those technologies. So about the Levi Strauss example, there is a massive lack of infrastructure in so many developing countries to handle big data and to do big data analytics. But on the other hand, I was reminded of this new term. So there's a term that's been introduced to counter the notion of brain drain. So it's brain circulation, and this is the idea of any number of people being educated in from the developing countries, being educated in Western universities, learning all these skills, and then returning to their countries and applying these skills and starting and doing the startups and getting cheap data lines and being able to do the analytics on the cheap. So I think we'll see analytics on the cheap on the one hand, but the storage remains in the West.
So if I think back to the introduction to these utopian visions, in this perspective, for the developing countries, it would be kind of interesting that all we can think of is self-driving cars, clean homes, and recommendations what to read. And is there anything more in big data and data analytics? Is there where is this positive power? How can it change the world or bring development to the countries? Anna, you an idea?
Change the world.
Change the world in 3 sentences or how much?
Yeah.
I could imagine that you can also use it for nutrition. That would it be to see all the harvesting throughout the whole world, optimize it, see when something wouldn't because of because of bad weather, can't be harvested. So you just have could somehow give a better flow of of all the nutrition goods you have. That would be one thing. I mean, that is really, it could help logistics in a general sense, not just bringing someone safe through Berlin, but really just make good way of logistic ways, make cheap and powerful tools there. And it could be in the health sector, I could imagine, with dealing with epidemics, like the Google flu charts, which are based on Google search. You can use other data, for example, identify when a real epidemic, not a flu, spreads, and how to condemn it in a good way, and how to deal with it, and have pre-alerts, have predicted systems which maybe try to identify where it could spread next and just react better. That would be maybe something which is not, in the bigger picture.
So why is there the epidemic of Ebola spreading, and we have all these brilliant companies who have all the data of the world, and I don't feel there much is happening to stop it.
Maybe because there is, at the moment, there's not the capability to produce data where Ebola is, for example, because it's you are too late in analyzing the data because it already spread it. If you would have prediction systems which are at the very beginning of everything, or even before the very beginning, it could help. But that is a longer way, because it's not a post-analytics on how it moved, but a warning system.
Maybe we just don't care. Yeah, that's it. I think that's what I say. Why should we use big data to make the world a better place? We didn't do it with all the other stuff. We didn't do it with the internet. We didn't do it with the smartphones. We didn't do it with the Twitter, Facebook. We didn't do it. Maybe we could, but we didn't care. Because honestly, it's all about business. We want to make money out of data. It's the new oil. It's not the new pool to make the world a better place. So honestly, there is a lot of value, and we could do projects to make the world a better place with the knowledge we get out of data. Yes, but honestly, we don't care. And that's the biggest problem.
Which can't be solved by algorithms.
So at this point, I'd like to open the discussion to the audience. Maybe there are some guys of you who are already doing this, doing good data science, and have some ideas of how to change the world with big data, or have some questions, comments. So please, any questions, comments?
Hi, I'm Stefan, and I attended a lot of market research conferences as well in the past, and worked in this field. And the funny thing is, and I'm pretty sure you all know this as well, market researchers can talk 2 days about representativeness of data sets, and how to draw a sample in a way that it represents the phenomenon, or all the people, or a population. And in a sense, and Richard, you touched that in your speech, this is kind of an old-fashioned thing that disappeared and is no longer a trendy thing to do, right? So it pretty much looks like, oh, these old guys. I mean, why did they discuss this so much? And as you would touch that, I was thinking, doesn't it have to do a lot with democracy? I mean, democracy is also about, building a system where people are represented in a fair way, and every opinion has a place and is secured and gets a stage and so on. So isn't this, just embracing the skewed samples and the data that is available, and don't care about the fact that only people are twittering who can pay for the service? The phones and the smartphones. Isn't that, like Klaas, like you said, again, an example of that we simply don't care at all about fundamental principles that influence democracy in our society at its core? If you think about, that it's rushing into universities now as well, and that traditional research where we did care about the representativeness of the data is being removed through data that is just available, and suddenly no research about people who are refugees or who don't have smartphones for whatever reasons is being done anymore. So aren't we risking much more than just an old-fashioned sampling technique if we proceed like that?
Who wants to answer?
Yeah.
I'm happy.
Yes, please.
Yeah, I'm happy to take some. So I think you raised a lot of questions, so I want to touch on 2 or 3. So one, I think the sampling was the way because we could not get to the data, right? So there's a very high cost of data access. So sampling was effectively, okay, let's take 2,000 because 2,000 is a good enough number that it's statistically relevant. If you suddenly have access to 1 million or 20 million or 200 million, then your data is less skewed. It may not, but you can normalize the data so that you kind of work out the skew, you don't do overfitting, and so we have statistical methods for that. So I think that the more traditional way, and we still do the more traditional way, for example, for TV, right? TV ads. So this is how we are measuring in certain media. But having all this data at hand, we can actually do better. And I think that's why there is this, after the big data hype, everybody wanted to do better, so people moved. That's how I see the more traditional one. I want to say something about, we don't care. I think in many cases, the technology we came up with, which had very directly monetizable ways in the first world, like if you look at Twitter or Facebook, or Google, I mean, they have artifacts, which when you start a company, you don't think about the artifacts, but they are really important. So for example, people organizing themselves through Twitter, through Facebook, and using it as a mechanism to kick out regimes in the third world. So if you look at it, well, what was the impact? It's probably, ultimately these are platforms to, place advertising better, sell products better, but there are side effects which are really important in other societies, which actually enable people who are not directly, addressed by, or not monetizable in the traditional sense why these companies have been created, but which leverage those platforms now as a form of media and can circumvent oppression. It's loosely organized. It's not in control of, certain governments who actually want to silence their people. So I think even though that we are building these things to monetize them because the first world is structured around this, I think there are side effects which are very, very positive.
Any other reactions? How to?
Yeah, go ahead.
Yeah, hi, my name is Nico. I'm the CEO of a company called Machine Schäfer. In a nutshell, what we do is that we generate and that we market personality data. And I have to strongly disagree with your statement that we in generally don't do good with data. Actually, our aim to start this company was to do good. What you have out there at the moment is mainly behavioral data that you connect with demographic data. Now, if people base their decisions not only on this kind of data, but also on the knowledge of their personality, then you can take very important decisions much better in the future. So we build products related to important parts of your life, health, job-related products, relationship. We help people to take better decisions, and of course we have an interest to also monetize this data by relating the data that we have to existing databases, for example. So we enrich existing databases, but I had a strong feeling that what you just said is completely different from what we do, for example, just as a different opinion to what you said.
Do you earn money with it?
Actually, yes. And with pretty interesting projects, and I think earning money is the basis of being able to run this business in the first place. But I don't feel bad at all by doing this.
That's good.
And I think,
of course not.
I think if you can combine both, make money with it, make money with this knowledge that you have on the one hand, but also have the feeling that you are building meaningful products, then it's a pretty good feeling, actually.
Oh, true. I totally agree. But we talked about how maybe can data or big data and what you can do with it, the developing countries. And in that sense,
well, we have a product dealing with how you can increase customer compliance or patient compliance of diabetes patients. I'm sure that there are not just diabetes patients in the developed countries, but also in the developing countries. And that's a product that is useful for the whole world, not just for Europe or the US.
Okay, no, sounds perfect.
So any
what else could I say?
Okay.
Hi, I'm Christoph, and I have just, I guess, a bit stupid question. Can somebody of you give me a definition of what big data actually means? So is this a size of this data set which changed so dramatically in the last time? So if so, what is the threshold between normal data and big data? Or is it more the kind of data, the purpose of what we want to do with the data? Just because we can record now everything, that the question is, okay, we have to do something with the data, and that the purpose changed a bit. So data-driven instead of, okay, what's our purpose? Yeah. So I'm just a bit confused. What big data actually means?
I was actually going to define big data at the beginning, but I thought, oh, everybody, you know. So the conventional definition of big data has to do with the volume, and it's that volume that can't be handled by conventional systems. So then people, when explaining it, will say, well, it no longer fits on an Excel spreadsheet. It no longer fits on a Fusion table. It no longer fits. And so you need special infrastructure. And subsequently, people talk about big data, define big data in other terms as well. That not only volume, but velocity. Like it's the generation thereof, the creation thereof, that is also quite big, because it's also fast. So it gets big very fast. So that's also about handling capability. It's also more complex because it's not necessarily. I mean, big data is oftentimes not necessarily thought to be all completely well structured. So it has this messy side to it as well. So big data has sort of, like, let's say, even more raw components to it. So these are some of the things, and then of course we talked about the implications of big data as being something that changes knowledge production in some ways. So we're moving away from, I mean, that sort of, you know, there's looking at a painting in an art museum and looking at the data about it, and it's there's two different means of interpretation, let's say. So this is just a couple of things.
Yeah, so it's more a kind of, so all these parts are actually not new, right? So we had, in physics, for example, the data was always kind of huge, and also unstructured data is not new, actually. Is it perhaps also that it is more related to, that because we record everything, it is more about that it's more related to social data, to personal data, and that's where the awareness comes from, that we say, okay, we have to think about these kind of data much clearly, or?
Yes.
I think it's for all kind of data. It doesn't matter which matter or which data. It's just that we now found a label for something to build a market on top, and that's called big data, which means all of what you said, but it also means that we have a lot of technology, a lot of open source, for example, open source stuff, a lot of algorithms which are 30 or 40 years old, which we can now use on this data to actually transfer what you did in your studies or in your PhD or wherever for maybe 20, 30 years to now move this knowledge and these kind of working with data and use fancy algorithms on data to the business world. And that's big data. So we are able now to work with the business data wherever they come from, how fast, how big, how structured, it doesn't matter. We use algorithms from machine learning, etc., and run it on top and create new business value. That's big data. But a lot of this is pretty old, actually. So it's old data. No, old big data, whatever.
Okay, I think we have time for one final question from the audience.
It's good to have the final question. Claudia Pohling from Deutsche Telekom, laboratories here in Berlin. I would like to ask the question again from this panel. What are the predictive trends and future technologies of big data? Maybe everybody of you can answer this in one sentence for 2015 or 2020. That would be great.
Okay, I think this will be a great finishing statement from everyone.
So I shall start. Okay. Well, yeah, I'm not an expert in this right now, so we have to start with it. But I think whatever comes out of deep learning might move us a bit further to come up with new kinds of algorithms which we use on big data. Because as said, everything we use now is 20 years old. So it's time for something new where we can create new things with the data. And maybe that's deep learning. But honestly, really difficult to answer.
Volkmar?
I think resourcefulness. So ultimately, we are using data because it's really hard to move things in the physical world. So we are trying to be more resourceful by using something really cheap, which is data processing. So instead of wasting, oil, wasting human time, we are actually trying to use predictions so that we stop doing the wastefulness.
Great.
I mean, if I were to make a prediction, I would say that we'll see a wholesale shift in the analytical techniques. So we'll see far more, let's say, machine learning in realms of life where we've never had machine learning before. And I think that the thinking through the social implications for that is extremely important. So I mean, machine learning for health, right? So the craft of the doctor or something that's under threat. So it's the implications of machine learning to me is that across new realms of application where they've never been seen before.
Anna?
I have the last word.
Yeah.
I more or less agree with the three of you because I think it would be new, or not new, but new adaptation of algorithms which are now more powerful or scalable because you have faster and faster machines where you really can use deep learning because you cannot use it in a real-time environment until now, but it may come true. I think it's the good usage of data so that you really try to divide maybe smart from big data or smart data out of big data, and that you may find really maybe not new fields, but evolve every field where you can have predictive algorithm be put in.
Okay, thank you. I hope this gives some impression of the trends, and we have until tomorrow to really find out what are the trends. We have the startups, maybe some interesting notions. And yeah, I want to thank you for your questions, and of course thank the panelists for the discussion and the food for thought. And if you have any further questions, I think we have a coffee break, and you can directly approach the panelists. So thank you very much.
Thank you.